In this screencast, we're going to look at the different components of a titration and how to solve a titration problem. Here's a titration as a whole process in the form of a graphic. We have an initial substance here on part A, and in our initial substance we have a very specific volume being added. They're using a pipette. So we have a volume of a particular substance being put in, and we do not know the concentration of that substance, but we do know how much we put in. Step B is adding an indicator. They're adding an indicator so that the substance will change colors, showing the equivalent point or the end point. Sometimes we'll use phenolphthalein, there's bromothymol blue, there's all different kinds of indicators, and they pick an indicator based on what pH they know that it's going to be neutralized at. For the most part, we're going to use phenolphthalein, which will turn pink from clear or clear from pink. Step C here, the third step, is they are using a known concentration, so known molarity, in a burette, and then we're going to read the volume as we add it. So we will have a known volume. Okay, they will continue to add substance from the burette into the flask until they see, in this case, the indicator change colors. The other thing that you may see is this would be titration based on pH. So they are looking for a graph and something specific to happen in that graph, which I'll talk about in the next slide. All right, so there are two different ways of doing a titration curve. You can do a titration curve based on a endpoint, which is using a indicator. So endpoints reference the indicator color change. And the picture here on the left where the pink is very pale, that is a good indicator change for phenolphthalein. If you happen to get this fuchsia here on the right, that is way past the endpoint, and you actually have too much of your base being added. The other way that you can do a titration is using a thing called equivalence point, and that is dealing with pH. And so what happens is as you add base to your acid, your pH is going to rise. And what happens is you can see that you can add a lot of volume of pH here, a lot of volume of base, and the pH doesn't change very much. And it eventually starts to get that as you add a very small amount, the pH is starting to increase, and it will get to a point where it will be like one drop will cause the pH to shoot up this entire area here. It's a very small amount. And that one drop, that point is called your equivalence point. So when you're graphing that, you're looking for that particular spot where the curve goes flat in a vertical location, and that is your equivalence point, and that's where you know that your moles were equal to each other. The graph here on the right shows two flat spots, two equivalence points. And the reason it shows two here is that this would be a diprotic acid. So this would have two hydrogens in it that are being liberated. So you have the first hydrogen being given off, and this would be where you're neutral with the one hydrogen. And here would be where you have the second hydrogen where you're neutral. All right, so here is the process for solving a titration calculation. The first thing that you need to do is you need to start by writing a balanced equation for both the acid and the base, and this is assuming you have strong acids and strong bases. So you need to make sure that you know the coefficients. Remember, an acid plus base makes water and salt, so you will need to write out whatever acid and base you have, they're double displacing, make water, and then correctly write the right formula for your salt. It may involve you crossing charges and adding subscripts. You may need to balance your chemical equation with coefficients, but all of that needs to be done prior to doing the titration. I would then write down all the information that they've given you in the problem. They're going to give you the concentration and volume for possibly the acid, and 1 bit for the base. So you're going to know 3 or 4 pieces. You're going to know at least 1 concentration and at least 1 volume for both an acid and or a base. I would write that down in your chemical equation so you know what you're starting with and what you're solving for. The next step is to determine the number of moles of known substance. So if you know the acid, find the number of moles of the acid. If you know the base, find the number of moles of the base. Remember, we're dealing in molarity, and molarity is moles per liter. You have to have the correct units. It is important and critical that you have the volume in liters. So once you find the molarity, you can find the moles. The next step is to use the mole to mole ratio to find the number of moles for your unknown substance. It's a basic stoichiometry problem. You're going to take the moles of the part that you know and find the number of moles of the part that you don't know. And then last, you're going to take the moles of that unknown substance and divide by the volume to find the new molarity. Sometimes they ask you for grams. Sometimes they ask you for molarity. It just depends on what the problem is seeking and what information you have. Alright, so here's a sample problem. It says, how many grams of CaOH in parentheses 2 are needed to neutralize the 25 milliliters of 0.0100 molar HNO3? I missed an M, so I'm going to put that in. This should be molarity. Okay, so let's start by writing our chemical equation. We have CaOH in parentheses 2, calcium hydroxide, and we have nitric acid, and we're going to make water and a salt that is calcium and nitrate. Now I'm going to have to use my prior knowledge to remember that calcium is +2 and nitrate is -1, so I'm going to crisscross to write the correct formula. After I've written the correct formula, I need to go back and balance my chemical equation. I'm going to put a 2 here because I see that I need 2 nitrates, and I'm going to put a 2 in front of my water because I need hydrogens and hydroxides. So my equation is now balanced. I also know that I have 25 milliliters of HNO3 and it is 0.0100 molar. I am being asked to find the number of grams of calcium hydroxide. So, first step, wrote my equation. Second step, identified what I have. Third step, let's find some moles. So we know that 0.100 molar HNO3 will equal some number of moles, and we have 25 milliliters, so 0.025 liters. Okay, when I do that, my number of moles is going to equal 2.5 times 10 to the -3, and that's my moles of my HNO3. Okay. Once I have that, I can use my coefficients, and I'm going to see that I have for every 2.5 times 10 to the -3 moles. So every time I have a mole of HNO3, every time I have a mole of HNO3, I have 2 of them, and I have 1 mole of the calcium hydroxide. So I would take my 2.5 times 10 to the -3. I'm going to divide by 2. I'm going to go ahead and finish this problem out. Once I have moles, I can change it right into grams, because this problem wanted me to answer in grams and not in molarity. So if I added it up, I'm going to get 74 grams of calcium hydroxide. So when I do the math there, my answer would come up to be 0.0926 grams of calcium hydroxide. Wow, having a little problem writing. My stylus is not being very kind. So as you can see, we did the basic steps. We wrote the equation, we identified the information they gave us, we found the number of moles of the known part, which in this case was the acid, and we then changed it into the moles of the unknown part and finished out the problem. This problem asked me to find grams. Other problems may ask me to find volume or concentration depending on what I was given.